Okay, let's add two vectors that are not at right angles to one another, and let's do a really good picture of this situation. Also, I'm going to give you a document in class that will spell out the 6 or 7 steps that go along with this. So hopefully I've given it to you prior to assigning this video. I'm sure I will. So I'm going to draw the rectangular coordinate system, because I'm going to be addressing it all the time. Please, if you struggle with drawing a picture, this is not imperative, but it's going to help me help you understand the answer to this problem. So I'm trying to move that over. So vector A is much shorter than vector B. It's about 7 when this is about 28, so it's about a quarter of the size at a 123-degree angle. So I'm going to try to draw a vector here that's about 33 degrees off the y-axis and kind of short. So there's vector A. Now this one's at 260 degrees, so this is 270 right here. You know, here's 0, 90, 180, 270. So 260 is really close. And I want it to be about 4 times as long as the other vector. I'm kind of eyeballing it. I guess I'm going to go there. And there's vector B. Now remember, if I can successfully draw a parallelogram, I'm trying to draw a line right now that's parallel to vector B, and a line right here that's parallel to vector A. I'm going to put a little cross mark right there. Then the resultant of these two will be from the tail to the opposite corner of the parallelogram. So it looks to me like if this line right here is about 29 units long, then do you mind if I estimate right now? Again, this is 29, this is about 7. I'm going to estimate, and I really am estimating that it's about 20. So I'm going to say the length of that line is about 20. Remember, this was 10 degrees. You know, that might be another 20 degrees, so 30. So what if we said that's 60 degrees? Again, just an estimate. That's what I think my answer is going to look like. However, remember when I report it in standard position, I'll go 180 plus this 60. So I might report that as an angle of 240 degrees. So again, just an estimate of what my answer is. But in order to do this, what we're going to do is we're going to develop a table that's going to help us find the x and y components of each vector. And I'm going to also draw those in once we've found those numerically. So first of all, I'm going to label the magnitude and the direction, theta. So vector A is 6.89 units in length, and it's at 123 degrees. I actually don't need this line. You know what, I'm going to go ahead and erase these. So I meant to put the 6.89 here and the 123 degrees here. So this is the magnitude of the vector, and this is the direction, and this is the name of the vector. Vector B is 29 units in length, and it's at an angle of 260 degrees. So remember, from a previous section, we found that the magnitude of the vector could be found by taking the magnitude times the cosine of the angle, especially if it's in standard position. So this 123 degrees is in standard position. So if you would type 6.89 times the cosine of 123 degrees, I'm not going to demonstrate these. I think you're fine. Got to be sure you're in the degree mode. You'll get 3.75. To get the y component, you'll take the magnitude of the vector times the sine of the angle. So would you take the 6.89 times the sine of 123 degrees and get a value of 5.78, and I apologize, looks like I forgot my negative sign right here on this 3.75. Let's go back and talk about that. So this was in the second quadrant, and in the second quadrant cosine is negative, sine is positive, so I should have gotten a negative result of 3.75 for the x component of this ordered pair that tips off right there. I'm going to go ahead and redraw this vector in blue. So I want you to see that this vector was made up of an x component that went to the left, 3.75, and a y component that went upwards to about right there, of 5.78. So look at what we just did. This vector got broken up into the negative 3.75 and the positive 5.78. I'm doing this very slowly and very carefully. So now would you take 29 times the cosine of 260 degrees? Both of these should be negative because we're in the third quadrant here. So this one should be a negative. I've got 5.04. And then 29 times the sine of 260 degrees, and I get for that one a negative 28.56. So again, would you look at these? This one's a negative number, kind of small in comparison to this negative 29. This one's a 5. I'm going to draw these in green. So this vector right here was just found to be made up of this negative 5 or so right here, and this positive right down to there, parallelogram, this, I'm sorry, I said positive, I meant negative 28. So this negative 5 and this negative 28 make up this green vector. But my final answer is right over here. So what I'm going to do now is I'm going to add up the x components. Do you see this negative 3.75 and this negative 5.04? I'm going to sum those up. So they add up to be a negative 8.79. And then I'm going to add these two numbers here. Let me show you, no, let's go ahead and do it, and then I'll show you why. So when I add up the y components, so I have to sum up the y components, I take the positive 5 and the negative 28, which adds to be a negative 22.78. Again, let's talk about y. So see this negative 3 and this negative 5? This is the green line, well, you know, actually my magnitude is not correct. This is the negative 3 and this is supposed to be the negative 5. But the bottom line is if I take this one and put it over here, I'm supposed to get to the tip of this resultant vector. And see this blue line right here and see this green line right here? The blue line is this 5.78. And this green right here is the negative 28.56. So when I add these up, I'm going to take this blue line and put it over here and come backwards. It's kind of like the current. I'm going downstream, but the current is fighting me. And I end up right here to get to the resultant vector of these two. So I had to combine this positive number and this negative number to find out what my x and y components are of the final red line. This picture can get to be challenging, and so if you don't draw a picture well, what you have to do is you have to look at the answers when you sum these up, and you can see that they're both negative. The x and the y components are both negative. That means my answer to my problem is over here in the third quadrant, because again, x and y are both negative. So I'm looking at this right triangle now because I want the magnitude of this line. So the magnitude of the hypotenuse will be found by taking the 8.79 and squaring it from right here. And the 22.78, don't bother with the negative signs because when you take a negative number and square it, you get a positive answer. I get 24.42 for that. Your reference angle, because you know you're in the third quadrant by your picture and by these are both negative, you know you're in the third quadrant. My reference angle is found by taking the inverse tangent of y, 22.78, divided by x, 8.79. I just got those from right here. The 22.78 and the 8.79. I did not put the negative signs on there so that I could get a acute angle between 0 and 90 degrees, which is 68.9 degrees. And then finally, because I know I'm in the third quadrant, my table establishes that if I take 180 degrees and add the 68.9, I'll get my final answer of 248.9 degrees. So the resultant is 24.42 at an angle of 248.9 degrees. Remember over here I estimated. I did pretty good. You could also say 60 degrees south of west. I'm going to stop at this point and do the next problem when we come back.